Hey, what's up guys? So I thought I'd make a quick video here showing you exactly how I test and program each of the pusher boards as I receive them from the factory. So in case you're building one of these up using a bare board or a partially assembled board, you can use this video as a guide for testing and programming. So I'm hooked in with my anti-static bracelet here. I've got my USB to serial converter hooked up to the computer. We're using one of my FT230X boards here. It's set for 3.3 volt logic and the power is off because we are going to apply power externally to the board with a power supply hooked up with this little JST connector. So let's go ahead and set our power supply up for 4 volts. Okay, that's powered up. I'm just going to plug it into the battery input to the board like that. The door switch I'm using for testing is just a standard little magnetic door switch. I'm going to hook that up as well. Okay, then I'll hook up the USB to serial converter, just like that. And right now, the board is awake. It's pulling about 70 milliamps, which is normal. That's about what it should pull. And keep in mind that these ESP-12S Wi-Fi modules are completely blank. They have no code running in them. They're straight from the factory. So now what we'll do is put it into programming mode, and this is kind of a challenging thing to do because the buttons are so tiny and they're spaced so closely together. It's hard to get your fingers in there. So typically what I'll do if I'm doing this a lot is take something like a Q-tip and break it in half and then use that to push the buttons in. But I got pretty good at it by simply first holding in the reset button, then press the GPIO 0 button, which is the center button, then let go of the reset button. And usually this, let me get it again there, I'll have to actually press that reset button just a few times to make sure that it goes into programming mode. So again, I'm holding the GPIO 0 button, the center button, in, and then pressing and releasing the reset button. Then I let go of the reset button. And it's a good idea to upload while holding the GPIO 0 button. So I just clicked the upload button in the Arduino IDE. We'll make a separate video here going over how to get the sample code here to compile. This is just about programming the pusher board. And of course I just opened this up for the first time, so it's gonna have to compile it there from scratch. And there it goes. So it's uploading, and once it starts uploading, you can let go of the center button, but it seems like I have much better luck if I'm holding that GPIO 0 button in to start the upload, and then I let go. So looking over here in the serial monitor window, you see that it woke up, it took the code, we got a timer wake, the battery voltage is 3.98, so that's good. That's pretty close to the 4 volts we're applying to the board. Looking at the input current to the board, it's at its sleep current, which is sub 1 microamp, so it's virtually disconnected from the power supply. So that is a good sign. Now we will wake it up and test the wake circuitry. So I'll take the magnet here, and the board is configured to monitor normally closed contacts by default. That's how the 0 ohm jumpers are configured. So let's go ahead and close that. So now the contact is open, and then we release that, and you see the LED turned on, and from the serial monitor window, we see the external wake, the battery voltage 3.96 volts, and it's mounting the file system, and this takes a couple seconds to do. This is setting up all of those variables that we keep in the non-volatile storage of the device. Basically, the things like your Wi-Fi credentials, the authentication parameters for the push bullet service. So all those things stored in memory. And there you have it. So it went through, mounted the file system, added the parameters, and then launched the AP mode. So now it's actually showing itself as a pusher, the pusher in the Wi-Fi manager. And if we were to connect to it over the Wi-Fi network, we would be able to pull up the captive portal and program it. And that, again, will be in a separate video. So right now, one of the things I'll look at is the current that's being drawn while it's in AP mode. and that's about 75 to 80 milliamps, which is perfect. I actually did have a board where everything programmed perfectly, went through all of this, but the Wi-Fi radio itself was not broadcasting out the pusher SSID, so I could not find it. It seemed like the radio part of the Wi-Fi module was not working. And I also noticed that the current was only around 20 to 30 milliamps. So I know this board is good. Took the code. It's doing a battery voltage measurement correctly. I have had a few boards that did not read the battery voltage correctly. I also had a few boards that would not wake. So anyway, that is my full suite of tests to program the board. A couple other things real quick I want to show you. I'm going to cycle power and then turn back on, and it immediately goes to sleep. So it got a timer wake because it just booted up, powered up for the first time, and then went back to sleep. So if you're in this situation and you need to program the board, it already has code and it already put itself to sleep. You actually have to wake the board up, and to wake it, you have to press the wake button. You can press and hold the wake button. Or you could wake it up with the external trigger input. If it is actually provisioned for your network, it's going to wake up and send the push notification out, which could take just a few seconds. So you have to be pretty quick in pressing and holding the GPIO 0 button and then press release the reset button. Or you can just simply press and hold the wake button. So that's the way I'm going to do it, and just show you how you do that real quick. So I'm going to reprogram this board now as if it already had code on it. Okay, and then I'm going to press the reset button and see if I can get in there on the GPIO 0 button, and then press and release the reset button while holding the center GPIO 0 button. I press the upload button from the Arduino IDE, and now it is taking code again, so it's programmed. This might seem like a big hassle, and it is. That's why this sample code also supports OTA, which is over-the-air programming. And with this sample code, you can actually, once you provision it onto your network, you can actually put it into OTA mode to upload new code to it wirelessly, just over the Wi-Fi network. So that's a very simple way to upload new code, and you don't have to mess around with these buttons. And we'll talk about that in a separate video as well. Again, this is just a video on initial testing and programming of the board. And every board that ships out from the distributor goes through this suite of testing. So there you have it. Thanks for watching.